All right. Welcome everybody to um, another session in the boot camp. It's been a long journey. I think this is the fourth week. And in the previous class, we started off with introducing us to Dojo, Dojo engine for building games, on-chain games, you know, games you can prove, verifiable games, awesome games actually. So the foundational work was laid in the previous class. Today, we are going to build on those laid foundations. By the way, I'm Victor Ifenda. And if you don't know me yet, you can call me country cousin as well. So I'm Manoah. He's the pilot. He's going to take us through and show us where we're supposed to be. Take us from where we are to where we are going to be. All right, Manoah, whenever you're ready, we are good to go.
All right. Good evening, everyone. Hope you can hear me.
Yeah, loud and clear, man.
Cool. I'm having a bit of issue with my network connection. That's why I'm not turning on my camera. It could interrupt it. Uh, so how are we doing?
We are fine. We are
All
fine. We are
right.
doing great.
All right. So in the last class, we introduced the Dojo toolchain and the framework. We tried to understand how it works. From understanding the tools we need to be able to build provable games on Dojo, and also how the frameworks look like. We explained that Dojo is built on an ECS system, which is the entity component system that differentiates data from the behavior or the logic of the game, right? And then this system does not apply to Dojo only, but it applies to other game engines like Unity and the rest of them. So that's just the difference between writing Dojo applications or using the framework with writing your normal Cairo code. But we agreed that, and we also saw the codes, and we understand that Dojo code are still Cairo code. Dojo systems are still Cairo contracts. Dojo models are still Cairo structs that we are still writing down. We also talked about Tori. I would say Tori is a special indexer that gets the data that was being created on the blockchain. It indexes it as fast as possible for the user to be able to get it in a more structured format, more easily, right? That's what we talked about Tori. So these are the components that make building on Dojo very, very possible. So we said you can build anything from an NFT app to the most complex games, 3D games you might think of on the particular engine. You could do it. So today we are going to try to build a very simple and relatable game that everybody will understand. It contains very short code that is concise and is working from end to end, which can be able to help you to continue building on Dojo with. It's also hosted on GitHub, so you can clone it and run it on your device. I think there's hardly any end-to-end example that showcases Dojo in the ecosystem, but this is going to be a good helper along other resources I'll be joining for you guys. All right, so enough of the talking. Let me share my screen and let's get to it. All right, so can everyone see my screen? Emojis, cool. All right, so this is what we are going to be building. We'll be building a simple coin flip game, whereby a user is allowed to choose between head or tails, and then a random number is going to be generated on the smart contract to determine what the side of the coin is, whether it's head or tail. So if it's head or tail, we are going to compare the two, what the user supplied, and also what was the outcome. So if it was correct, let's say I select head and the outcome is head, I am going to get a win. But if I select head and the outcome is tail, then I lose to the game. So let's try this out. So let's select head, it's flipping, and then I didn't get this time around. It's flipping. I also lost. What's happening? Let's go head. Cool. So it also calculates your win rates to know how you have been winning, how many wins you got out of the total flips that you did. So it might interest you to know this game I just played is happening on chain, though currently not on Sepolia, but built on the Katana game, the Katana sequencer, right? Local sequencer. So we talked about the Katana local sequencer too in the last class, and I told you guys it's a local version of the blockchain like Anvil that we can use to be able to test our games, even test our local smart contracts. I'm also going to be giving guides to help you to deploy on Sepolia and also integrating the cartridge controller by the end of the class. So that's what we are going to be doing today. All right, who is pumped? Let's get to it. Before then, let me get a little bit of flips and win some more. All right. So this is currently hosted on GitHub. Should I send it now or give it to the end of the class? But for now, let's work with it. So the first thing you want to do is to create a folder that is going to host our Dojo smart contract and also the client side, which is going to be built in React and Vite with TypeScript. This is going to be that's going to be the tech stack we are going to be using. So the smart contract will be in Dojo, Cairo systems. Then the front end is going to be in React with Vite, and we're going to be using TypeScript to make that possible. All right. So I also said in the last class that you guys are supposed to install all the necessary things to get started, like Sozo, Katana, and Tori. That's why I introduced them. So for this class, we are going to be using the version 8 of Dojo. So let me create a directory and get to it. Then let's call this. All right, all those long stuff just to open it. An IDE. So let's get our terminal ready. So the first thing we are going to be using, if you are installed, we are going to be creating the contract side of things, which is going to be our Dojo contract. And then we said the tool that can help us do that is Sozo, right? So with Sozo, we can be able to create new projects, run deployment, test the systems also, and also run deployment with Sozo. So let's try to create a new project now. So to create a project, we say Sozo init, then the name of the project. So since we have already created a parent project called CoinFlip, I'm going to just call this contracts. So we know that this is where our contract exists. So it's currently starting and it's setting up the project tree for me, project directory. By the way, can you guys see my screen or should I zoom more? I think we haven't got into the code yet, so no need. Uh, okay, so I think my network is, because it's taking a lot of time, which is not supposed to. But let's just hang on. Okay. So guys, just give me a sec. Let me try to like switch my network as fast as possible.
let's just wait and hold on for him to rejoin.
All right, guys. This should be better now. So are you with me? Are you still with me?
Yeah, we're here, man. We're here.
Cool. Just hold on a sec for me, guys. Let me get another one.
First one is the launch with.
Yeah, can you guys hear me now?
Yeah, we can hear you, bro.
All right. All right. So the previous network was really terrible. So this just did it like real quick. Had a lot of complaints about MTN and Airtel these days. All right. So we have our projects bootstrapped and we could just have a look. We have already seen this from the last class, so there'll be no need for that. So let's just get to work. But probably for those who are not in the last class, but most of the names here looks familiar. Uh, this is, forget about this VS Code and these assets. This is the source folder where all our code lives, our Dojo models, our systems. This is where we write all the Cairo stuff and the Dojo stuffs that get deployed at the end of the day. Forget the git ignore. I'm sure everyone knows that. This is a tool file dot tools. Don't ignore this. This is a very important file because it contains the current version of stuffs that we are working with. So for this project, we are working with Sozo, version 1.8, Scarp 2.31.1. And I think we also need Dojo here. So instead of Sozo, let me just fix this. So this is a very important page. Then these are Docker related files for those people who are going to be running it in a Dockerized container. Because most of these things work with versions, and then you will, if at times there are breaking changes in some of these versions, and it can affect what you are doing. Like most of the errors I've run into when I'm building stuffs is probably because I'm not using a version that is compatible with another dependency that is using another version. So always take note of your versions. So that's why people use the Docker files, but I'm not working with Docker. Then we have the dev.toml that contains it contains all the setup for the toml for the dev development. So when we want to deploy to the dev environment, which is Katana, this is the setup we're going to be working with. So the namespace, Dojo starter. To make this possible, they have the account address and then the private key, which is. But in the Sepolia environment, remember I told you guys you are going to have this in an EFV file. But this is because this is a public network that is not real phones. So it's not needed at all. Then the writers. The release file. Then another important file is the manifest. So the manifest, remember I told you guys, it gets generated when you are deploying or migrating an instance of a contract. But for this file, we have one that is already set up. If you check the systems. So that's why we have the manifest. But we're going to clear this now and put in our code. So we're going to be building what I showed you guys in different phases. So in step 1, we have already initialized the project. So for step 2, we are going to set the version, which is what I already did here, to Dojo 1.8.6, because this is the version I'm working with. If you want to know your Dojo version, or you want to know your version, you could just say, just call Sozo or Dojo dash version. I showed you guys in the last class. You'll know what version you have. Then some really important file is the scarp.toml. So this contains all configuration that gets deployed at the end of the day. So that's going to be the step 2. So after you initialize the project, we are going to configure our project. Like basic configuration, like the name of our project is not supposed to be Dojo Starter, right? It's supposed to be named, let's say, coin flip. So let me check the time and see, oh, right, we don't have time. We have to work real fast. So we got coin flip. The version of Dojo is 1.8. These are some of the scripts, though we don't need this for now. Some of these scripts for now, we can change them. Then the dependencies that this project is going to be using. So it's using Dojo, and then it's using Starknet version 2.13.1. So always mind your Starknet version, because we install Starknet separately with Scarp and the rest of them. But with Dojo now, mind the version that you are working with. So the most stable version of Dojo, I would say you will use is from 1.7 and above. Then Starknet 2.12, 2.13 is okay. And you are good to go. So this is just basically the configurations. So I can just switch. Let me switch to what I have here. Completely to this. So this will be the new configuration. So what's our game mechanics? That's going to be the next thing we are going to be defining. So our game is just a simple flip game. We have a player, which is you, and then a coin. He flips the coin, and then you select a prediction first before the coin is being flipped by the system in a decentralized and fair way. Then if your outcome is the same, if the outcome is the same with your prediction, you win. If the outcome is not the same, that means you lose. So let's get to writing the code. So first things first, we want to model our system. What did we say our models are? Models are set of entities and components which are data. They are key value pair sort of data that are being stored or indexed by Tori for us to get on the client side. So basically those are model. They are structured data that store our game states. So these are the files I'll be working with, models and then actions that contains all the game logic. So let me clean this up. I want to move really fast as possible. So then the tests, I think we wouldn't be needing most of this. Take it out also. But we can leave lib.cairo since it's all connected together. So lib.cairo is the entry file that defines all what we are going to be working with, like the systems, all the models here, so that when we are trying to migrate, we can be able to have access to them. So let's structure our game now. So to structure it, that is to get the model, is what we'll be doing it on the models page. So first, we are going to create a public struct so that it is available everywhere within the game. So this struct is for the player, the person who is playing, so that we can be able to track details of what the person is playing, how many wins, how many losses he has gotten, how many flips has the person done, and all those sort of cool stuffs that we can display on the front end so the game becomes more intuitive. And then for you to be able to get a player, you have to supply us with a key. And then the key, which is the entity, is a contract address, which is the address of the person making the call to the game. So to get contract address, we get it from Starknet, right? Starknet. And contract address. All right. So the address, which is the key, is going to be the unique identifier for the player. So anytime we want to get the player details, we can be able to identify the players by his address. So anytime you play our game, you just say connect wallet. You try to play, you make your flips, and then when we want to fetch your details, we get your public key or your wallet, your account address, and then we use it to query the system to be able to get your, with Tori, to be able to get your stats from the player model. So the components we are going to be attached to this is the total flips. So first we want to track how many flips the person is making. So anytime you make a flip, we are going to increment. And then it's going to be U32. So I don't know how many times you like flipping, but when it gets to that size of data, you should stop, right? Then next, we are going to know how many wins. So we are going to be tracking your outcome at the end of the day. You know, when you are playing the game, if you place your guess, your prediction, and then the flip is being done, if it's correct, you automatically win. So with that, we are going to increment this number so that we'll know how many times you have won. It's also going to be U32. Though I love winning, so I will have said U256. And then while we are counting your wins, you also count your losses, right? Which many a times is going to be higher than wins. Irony of life. Okay, but then this is not enough. So first of all, we have to let the system know that this is a Dojo model. And how do we do that? We have to annotate it with this. Very important. That says Dojo model. Let me select. Oh. So with this, notice the Dojo model. Then we also implement some traits from our native Cairo to help us to be able to copy this data, to clone it, to serialize it, which is to change its type, if maybe we want to do that. Also, we could print it and the rest of them. So those are the type we're going to inherit currently, the traits. So that's the drive traits. So as Cairo devs, you are not supposed to be staying long with this. So for copy, for dropping, for serialization, and then for printing or debugging, the bug. Cool. So we have our first model up. Then the next model we want to have is the model of the game itself. So this model is going to keep track of every player, the particular game the player is playing, the prediction, the outcome, and then whether the person won or he lost. So it's basically almost the same thing that is being saved in the player that we want to save in the game, so that we can be able to track all the amount of games that are being played, right? So we have a game ID that is being incremented every time, just like how we are tracking the total flips of a particular player. So same thing, we also create a public struct. So no time for that. Let's just get this as fast as possible. We change the name, we call it game. Then this time around, it's going to have two keys. And then models can have two keys. So to be able to get a game, you need to pass in the player address and the game ID, because the player is going to be playing multiple games, right? And then game ID is going to be a U32 to track the amount of games you have played. So game ID. So let's take this prediction. Wait, so the prediction that you are making is either head or tail. And then in the app, we are going to be storing it as either 0 or 1. So in that case, it is a U8. And then the outcome at the end of the day, right? So the outcome also is going to be U8 because the outcome is either head or tail. Then a Boolean that states whether the game was won by the player or not. So with that, we have our second model up and running, and we are good to go. So everything is done. We have this set up, and we also have what's very important, the model attributes, which tells Story to index this data. If you don't put this, Story will not index it. And the Story we are working with on the front end. So always remember that. So the next thing after creating your models is to get your system started. So currently all is cleared here. And then a system, like we said, is a Dojo contract. So kind of looks like it's Starknet contract, Cairo contract, which is 100% a Cairo contract, right? So let's call this actions, which is going to be the system of the game. And then to know this is a contract, we add Dojo contracts. Right. All right. So we said the systems are where we can be able to manipulate the data being stored in the model, either read or write to the models, right? Which is the basic things we do as blockchain developers. So to be able to get that model now, we have to get it from the game, from the models file, which we can say use, then use what? The name of our game now, which is coin flip. So we say coin flip, and then models, then all the models. Models are player and game. Those are the two states we are tracking. All right. So we are good to go. So the next thing now, what are the functions we want to be able to run in our game to make this possible? So for this game, it's very simple. This game has only one write function, which is going to be the function to flip. That's going to be the only job the user is doing, just flipping. And first, I'm going to define a trait for this because it's going to be public so that everybody can be able to access it. We do it the normal way that we do it in Cairo because it's Cairo we are writing. And then for now, it is using the T generic. So the function flip, and is a write function, so it's going to reference self, which is T in this case, and it's going to be accepting only one parameter, which is prediction. And prediction is type U8. Does the function return anything? No. It just runs, and then we know on the front end if it works or not. So this is going to be the function where we write everything. So the next thing to do, everybody knows this, is to implement this function within our game, right? So this is actions implementation because there's no traits without implementation. Hope everybody know what traits are for. The trait is just the blueprint. Then you could write implementations for them. It helps in interaction and implementation. So in this case, what we are doing now is implementing. And when other functions when other systems or contracts want to interact with us, they use the trait also. Somebody's hand up.
Yeah, I'm sorry. What's the difference between trait and interface?
So basically, they are the same thing. One programming language is just telling you interface, the other one is telling you traits. Are we good? All right. So this is the action implementation of the traits, actions, and within this contract, we are going to be working with the contract states instead of T. So it's yelling, it's saying I can't find action. So where do we get action from? We get it from outside of the scope, which we can access with super. and we call it in I actions. All right. So action implementation is also yearly. Why? Because it has a function that we have to implement inside of I action. It is implementing I actions, and I actions has a function in it, which we haven't written yet. So that is what we are going to be writing now. So the function to flip, a write function that reference self contract states and the user's prediction, which is UIT. It doesn't return anything. So you see, we are good. All right. So because these are the traits, and I want you to generate an ABI in the manifest at the end of the day, I am gonna annotate it with this Dojo, or no, ABI implement, ABI embed, underscore V not. So most of the times you don't have to have this in your head, you just oh, so you see, it's also giving a warning. This is supposed to be annotated also with a Starknet interface. So we are good to go. Because you are implementing and then you are not saying it's an interface. So can you see the name interface comes here, right? I didn't use traits. It says interface, so there's no need for any long explanation again. All right, so what's the flip function going to be doing? So the flip function has a very simple job. It's just going to check our prediction and then get a randomly generated outcome, which for now is not going to be very, very robust. It's just going to be using our timestamp and block timestamp to get the random number. And then we compare the two of them. So if it works, then we flip and then tell the user he has won or not. Then we write to the model, write to the player model. All right, so first things first, we assert that the prediction is equals to 0 or prediction is equals to 1, because we are predicting only head or tails, and the head is 0 while tail is 1. So these are the only two things we need the user to be able to supply. So that's why we are asserting that. Then the next important thing we need to do is to get the world. So currently, if you notice, we said in Dojo, we work with ECS, right? Meaning models are separate and the logic is separate. So currently, the model is separate from this stuff. Forget that we have already brought them here. So to be able to assess the model and also assess the state of Dojo or the state of our smart contract in this case, we need to get the world within the system to be able to, when it writes to the model, it's going to update the world automatically. Because remember, I told you guys, systems exist as their own separate smart contract, right? But at the end of the day, there's one single smart contract, which is a world contract that is being deployed. And that is where everything exists. That is where the data exists, which is the model and the system. And then two of them are going to be interacting. So first, we need the world before we are going to be able to do anything. And then to get the world, we are going to write it as a private function for more security. And then we can just implement it as an internal trait of this contract. Then self can be able to use it. So let's say internal traits or internal implementation of internal traits. So the function world default, get the world. It's a read function. So as you can see, it's taking a snapshot of the contract states. Then it is returning. At the end of the day, it's going to return the total world storage. So to get the world storage, we say Dojo. We get it from Dojo directly. Then we return. We read and return it automatically, explicitly. So we say self.world. Then what is the world we are working with? At coin flip. So the name of the world normally is the name of the namespace that you specify in the dojo.dev.tommy or in the scarp.tommy. So we are going to try to fix that. So internal is yelling because instead of I put T. Traits not found. Okay, so I have to make this add the generate traits. So that is going to generate the traits for me if that's what it does. Yeah, and I'm good to go. This is an internal function that calls the world contract, and then we can be able to access it inside of the whole contract here at the end of the day. So to get the world right now inside of our game is very easy. We just say self dot world. Self dot world default. We call the function. So that's it. And then we can save it in a mutable variable called world, since we are going to be reading and writing to it within the whole app. And with that, we are good to go. So to make this possible for us to have access to writing to the state, we need to bring some stuffs in here from Dojo. That is the Dojo storage and the Dojo event storage and the Dojo model storage, so that we can be able to store events and models on the go. So all these are inherited from Dojo. Yep. And then, so we have our world. So the next thing now is to try to read the player status. Let's know who the player is before we can be able to make a flip, right? So that we want to add how many flips the player has done, and we want to know whether the player has won or lost. So at the end of the day, we need to get the player details currently. So you do it the normal Cairo way. Let caller equals to get caller address. I don't know if we have put that in. Well, we haven't. So to bring that in, it's easy. We'll just say use Starknet gets caller address. Yep. So now let's read from the player. And then you remember we said the models are what store the information, right? So for us to be able to read from a model, we need the entity, which is the key. And then the key is the player address. That's why we got the player address here first. And the player address we got is from who is calling the flip function at that time. All right. As developers or smart contract developers, you already understand all these concepts. So to get the player model, all I just need to say is world dot read model. So this is the storage that allows me to read model. And then I'm going to pass in the model. That is which model the key. What is the key? Which is what can be used to find the model. I say caller. Then how does it know which of the model I am working with? So let's call this mute, save this in a mutable variable, call it player. And then the type is player is equals to world. Cool. So now it works, but I haven't bring the player model here to know what the data type is. So I have to bring that in. But I think I've brought that at the top, right? Yes. So let me use super to just bring it in. And then I say player or game. Yes, and with this, we are good to go. So now we have the player details, and then we can be able to do any stuff we want to do now. So the next thing we will do in this case is to generate a random number that is going to generate what will be the outcome. Since the user has generated his prediction, we will now generate an outcome and compare the two. So in a normal sense, this is supposed to be in a VRF, which is a verifiable random function, to be able to get this on chain. But ours is not going to be like fully verifiable. So we are just going to be using the block timestamp to get our randomness. So to make this game much more better, I think for the hackathon, there are other use cases that exist for like building privacy verification functions to be able to get randomness. So maybe you could improve this game to submit for it and stuff like that. But having a better game will be a better fit, right? So first, let's get the timestamp. So let's say timestamp is equals to regular function get block underscore timestamp. We call the function. And of course, we haven't brought that function in. So now we've gotten the timestamp. So now let's generate the randomness. The randomness will be the outcome. So let's say let outcome be equals to, so let's do the mathematics. So since it's 0 or 1, let's just check if the current block.timestamp is divisible by 2. So with that, it gives us a U8 value, either 0 or 1. Oh, sorry. Then we it gives us a Boolean value, then we can be able to convert it back to a U8. Because Booleans under the hood are 0 and 1 too, right? So if we say timestamp modulo 2, so in this case, it's going to check if timestamp is divisible by 2. So if it's divisible by 2, it tells you either yes. If it's not divisible, it tells you no, which is true or false. Then we convert it using try into or wrap. So this will convert the function, but then what data type do we want it to be? I haven't stated that, that's why it's giving the error. So I say this is a U8, which can be the outcome. All right, so we are good. So already have the outcome. So now the next thing is to do is to compare. So let's know whether the user won or lost. So let's say let won is equals to prediction, which is what the user predicted, either 0 or 1, is equals to outcome. So what's the time now? Okay, cool. So we check the 2. And then if it is equals to, you know what to do. We set the stuff we set the player details to 1, and then we also increment the count. And after that, we also increment the flips. So for now, we'll just say let's new game. So the first thing we'll do, since we have already generated an outcome and the user has flipped, we are going to increment the flip now. So let's say, let's call it total flips is equals to, then we get the player dot total flips from the model. Then we add 1 to it. And now we've gotten the total flips. Then we update the player's total flip before we write to the model by saying player dot total flips is equals to underscore total flips. So now we have incremented the flips because the person we have already have an outcome and we have already predicted the 2. So the next thing is to check if the play user won, right? By checking the outcome, prediction equals to outcome, true or false. It gives us a Boolean value. So if true, that is the user won, what do? We increment the player wins. So we say player dot wins plus equals to 1. Else, which is the opposite of winning, losing, that everybody hates. We say player dot losses plus equals to 1. All right, so with this, we are 100% sure that we have incremented your wins and your loss by checking your won outcome. Then the next thing, we are going to model the information that we are going to write to the player and the game model. So currently is the game because the process of flipping is a game that's currently being created. So let's do that. So to create the game record, we say let's game equals to the game model. Then the player of this game is who? Is the caller. in the game ID. In this case, let's use the total flips since it keeps incrementing. So the game ID is the total flips. Then the next thing we need is the prediction. So what did the person predict? So first, let's look at the game model. I think that's why I'm confused. This is it. All right. So in the model, we need for the game, we need the player address, we need the game ID, prediction, outcome, and then whether the person won or lost. So I write the prediction, outcome, then either he won or lost. Oh, what's happening? Missing member address. Oh, okay, so let's do this. Dojo contract, missing member address. Oh. So it's not supposed to be player there, it's supposed to be address. The problem was just looking at me. So I've modeled the game. Now the next thing is to write to the wall. So we say wall dot. So to be able to write, we have already done the read model. You pass in the key, it gives you the stuff, right? To write, you say write model. So wall dot write model. So this is not different from what we have been doing. It's the same thing. It's just some new concepts that have been implemented. So we update the game. And then lastly, we also made some updates to the player by adding his wins and his loss. So we're also going to write that. So we'll say wall.write model. Nice. Then in the end, we talked about one very special important thing, the events. This function now is ready, but there's one thing that is missing. Tori indexes our events and our models. And then events are very important, which is what we can use to query data as fast as possible. So we don't have an event here. So let's create a new event. So to create an event, you do it normally. Okay, that's why I even brought the event storage. So I'm going to create a new event, public struct. I'll call it flipped. Normally events have keys, so don't look at, so you understand the concept of where models are coming, right? So for people that have built with subgraphs before, how many people have built with that? Let me see your hands up. Nobody. That's serious. So how do we know this is an event? We call this a Dojo event too. So that Tori is going to index the guy. We don't have time. We have to move fast. But we're already finishing the contract. Then lastly, we can copy, drop, and serialize too. So let's just get that and drop in here. The main thing is everybody understands the concept. All right, so anytime a user flip, the event is going to get who flipped, who made the flipped, and store it as the key. It's also going to get the game ID, that is in which particular game did this flip happen. What next? It's going to get the prediction, what was being predicted by the person playing the game, so that we can get it as fast in the front end. We're also going to get the outcome. And finally, we are going to know if the person won or lost, all in this event. All right, so we are good. So the last thing we have to do here is to emit this event, the same old thing we do. So we say world.emit events. And then what's the name of the event? At flipped, because we just flipped. And this is the data that we want to pass in. The player, which is color, the game ID, which in this case is total flips, the prediction, the outcome, and what if the user won or lost. So with this, the event is successfully indexed. So congratulations to us. We just wrote our first Cairo Dojo system and integrated it with a model. But moment of truth, we have to build this and be sure everything works. That is going to be the next step. Though we are supposed to test, but I think we don't have much of the time. To test is also quite easy, so you guys could try out the testing. So, but I have a test file here. Maybe I could just paste it as fast as possible. Then we run through it. So in the test world, I'm just going to paste this guy. So this is the test that's sure that everything works fine. So in Dojo, in Cairo, normally, you have to declare and then deploy the contract. Then you get it and work with it, right? But in this case, we are working with namespaces. So you have to define a namespace in this case, and then you get it from the test resources. So in the end, from the model storage and the world storage, you can be able to Dojo arranges all of these events and models in different selectors that we could use to get them, right? And then with the class hash, you can be able to get the whole resource, which is going to help us to query within the test file. So to be sure everything works fine, we are going to build by saying sozo build. I click enter. So don't panic. This error is as a result of not being in the contracts folder. So I call it again, sozo build. And then when it's building, it generates a target folder and then it's finished, EP, so meaning it works well. So it generates a target folder where we can be able to see every stuff that I did, right? So you can see all the things I told you. You could look at them if you want to. So this is for the dev environment. If you want to deploy on Sepolia, you do your setup. You are going to say sozo build -p, which is going to be the flag Sepolia. There's a way you set it up. I'll show you guys if there's time. But for now, let's get going. Then to be able to test, let's say sozo test. All right, so we ran one test and everything went fine. So our contract is completely fine and we are good to go. So the next thing now is to start trying everything to be sure everything works out. So first, let's deploy this in a local Katana environment. We're already done writing the stuff. We'll deploy this in a Katana environment. Then we are going to try to test it in the CLI. That is going to be the part 2 of this project. So to deploy in Katana, from the Katana documentation, this is the code. You just say Katana dev in the contract folder, -- no fee, HTTPS course origin all. So with this, it's gonna fix the cross origin issue so that, you guys don't need to know about this for now. Don't worry. When we get to the error, you guys will see it. So let's start the Katana server. And then it started. It's currently in localhost port 8080, which is the local place it always launches Katana. Then we have this bunch of pre-built accounts that we have here. So the next thing is to try to make our deployment. So I switch to another terminal and then I say sozo migrate. So this is the code to deploy. If you want to deploy on testnet, after you have already set your Dojo Sepolia.toml setup and you have done the necessary stuff, you just say sozo migrate -p and to do that for you. In short, there's a script that will help you out. So no need for all that. So let's say sozo migrate. Then we wait for all this to go well. So it has checked the difference. It is verifying the accounts. Now it's deploying the world. So hope this goes fine. All right. So the world is deployed at block 2. It's trying to declare the resources and then register external contracts. Currently, it has initialized just one contract, which is action systems. If we had multiple ones, it would have initialized like 2 or 3 and stuff like that. And it has also granted permission to it. So our world is currently deployed on this address. Great. So the next thing now is to try to make function calls to be sure everything works fine. So let me open, let's try to make some calls here. So to execute a flip, to be sure it works, I say sozo execute. Then I call the namespace. The namespace is the name we stored in scarp.toml, remember? This one. And then I think in the dojo dev.toml, there's a setup. Okay, so we are supposed to fix this guy. We'll have run into a problem, guys. But let's try to run into it first. So I say coin underscore flip dash, I call which of the system, which is actions, right? Then I call the function I want to call, which is flip, and then provide my outcome. My outcome is 0. Click enter. So you see, contract coin flip actions not found in manifest. That's because I didn't set my Dojo dev toml well. It's still using the default Dojo starter. So if I check my manifest, you see the name is still Dojo starter. So if I want to access it, I have to use Dojo starter in this case. But I don't want to use Dojo starter. So in this case, I will fix my toml file and then redeploy. So where is it? I don't need all this long, guys. So the writers in this case is going to be coin flip. The seed, I'll still call it coin. Flip. Yeah, then the namespace, the default namespace. I still call it coin flip. And with this, I'm good. Right? So in this case, to be able to access the writers, is going to be in coin flip dash actions instead. So let me try to migrate again. All right. So I've migrated and the manifest is written. So if I check the manifest now, it should be well set. Oh yeah, so everything is regarded as coin flip, blah, blah, blah. So let me run that command again. Good. So the command to execute on the CLI with Sozo to execute a function call. So if this works well, I should get a transaction hash and EP. So I have a transaction hash and then everything works. So the next thing now, my smart contract is good to go and I want to start working on the front end. But remember, we said when working in Dojo, all your events, your models are being indexed automatically by Tori. So, but in this case, we haven't started the Tori indexer. How does Tori know that it has to index everything? So we have to index the world. So to index the world, we have to make this single function call that is going to help us index with Tori. So we'll say Tori dash dash world, and then we place the world address. So let me just copy and get this. For those of you who have been in the docs, you should be able to see this before. So this code, and then I copy the world address from here. So Tori dash dash world, this, and then in the end, I'm saying that the HTTP cross origin X, meaning it should allow cross origin resource sharing with other ports, right? So that I can be able to read this on the front end because, you know, our React server is going to be running in ports 5173 if we are working with Vite. If you are working with Create React app, you work on 3000 on Next.js. But our Tori client is running on port 8080. That is the location when it's running. So we have to allow cross-origin resource sharing so that we can be able to read data from 8080 in 5173. So enough of the big English. Let's just click on enter. And right now what's happening is that Tori is currently indexing our data. So if you are doing this in Sepolia normally, it's going to generate two URL for you, which is the Tori URL and the relay URL. That's what you can use to read and get data from the front end and the rest of them. All right. So how am I sure everything works? Tori runs on port 8080 locally, right? So let me try to start that up. I think I already have it started. You know what? Let's just call this local host 8080 slash GraphQL. So currently to load all the information, and then with this, I can be able to read all my data from the front end. So this is not supposed to be here. This is because I've read one of the code. Yeah, so on default, it gives us these coin flip models, the edges. We can be able to get the total flip, wins, and loss of a particular address. So let me just make this call. So can you see? This is my address, FCEC, which is the Katana address given to me here. It is the first address given by Katana. You can see it, FECEC. So that's the address that's been making the calls. And then I have only flipped just once. And I have 1-0, and then I lost in the last game. So let me try to flip again and then come back to check it. Good. So I flipped again. Let me make this GQL call. So you see, I have total flips, and then this time I won. So 1 win and 1 lose. So we are 100% sure that Tori is indexing our data and we are getting it, and our smart contract or Dojo contract is working super fine. So the next thing we are going to do now is to start our React app and get this integrated from end to end. Wow. So I think we have a bit of time, about 40 minutes roughly to round things up. So that should be enough to write a real React app and even take questions at the end of the day. So who is with me and who is pumped? Let me see. To be sure we are seeing the class. All right, Peter June, John Bosco. Who are those that came late? Ramat is cold. Let me get water, please. Guys.
I joined late, but not too late.
All right, guys. So the next thing we want to do now is to create a React app. So I'm creating this app with React with Vite. I'm going to have a lot of terminals open, so don't mind. But hope you guys are seeing my screen. Because if I zoom this, it's not going to take as much details as possible.
It's kind of tiny, but then you can manage.
I like that. If you can manage. But don't always manage. But this will help out where you are trying to like rewatch the tutorial. So you can zoom the screen by yourself. But if everyone is in favor of we increasing, I think I can. But I'm enjoying this. All right, so we are going to start up a React app with PNPM. Normally, when you are working with Dojo.js, it is recommended to work with PNPM. That's what it says in the documentation. I really don't know why. But if you are stubborn, you could work with NPM or Yarn. That doesn't mean it won't work. To still work super fine, maybe. I think I've worked with Yarn before. But in the documentation, they recommended PNPM. So I'm going to start a new PNPM app, and then it's going to work with a React TypeScript template. It's going to be a Vite. Yeah, I'm going to be using create Vite, and then the name is going to be client. So as soon as I click on enter, it should get to doing that. Whoa, funny questions. Experimental use? No. Store npm? Yes. And then to get more space, let me toggle this guy. Yes. So this is better. All right. So we have a React app, bare minimum started. It's ugly, so we don't want to see it. So now back to the React. For those of you who haven't seen a React TypeScript project, this is it. The app.jsx, the main file, and then let's get to it. So did I install this? Okay, it ran the installation and started by itself. Oh, I was wondering. So the next thing I want to do now is to install the necessary dependencies I'll be needing for my front-end application. And then in this case, I have the following. So let me see the out of this CD to clients. And then I'll use PNPM to install the following dependencies. I am using Dojo Engine Core, Dojo Engine SDK, Dojo Engine Tori client, and then I'm installing Starknet version 8.1.2. So click on enter to install that with PNPM. Then I am going to be installing the Apollo client and GraphQL. So you guys remember I said in Dojo, what Tori does is that it just indexes this data, get them in persistent storage so that we can have them in SQL formats and also in GraphQL formats and the rest of them. So to be able to read those queries, we are going to be using Apollo to help us. So we'll generate our GraphQL queries and then we'll use Apollo client to be able to read them. So for those of you who are familiar with GraphQL, this should be a win-win situation for you. So that's why I decided to use some of these technologies. There are different ways to get Dojo data on the front end. It totally depends on the type of game that you are building. So many times in the documentation, it shows you the Rex format. So you are trying to set up the front end and things are very, very cumbersome for you. That's because the setup that is there is because it's for high-end games that uses the Rex format. So with that, it subscribes to entities, and anytime you're making call, there's an automatic subscription that updates the front end. That's what normally happens in all these high-end, like 3D games, 2D games, or games that need more higher functionalities. So those are the implementation they do on that end. But For this our game, it's just a very simple stuff. We just want to make the click and then read from the query from the database which is stored. So this time around, we're going to use GraphQL queries. That's why we are working with Apollo client and GQL. Let's see. Whoa, 15 minutes. All right. Then lastly, let's set up all the necessary TypeScript stuff to be sure Wasm, bytes is all good to go. You know how TypeScript behaves. To be sure it's all safe and typed. All right, so we are good to go. We have our front end set up and we have installed all the necessary dependencies. So if you notice in the game, I wasn't doing any connect wallet, like wallet connection. That's because for this demo, I am using the Katana environment and Katana has already deployed wallets for me. So all I just need to do is just get instance of the account with Starknet. If I pass in the private key, I can be able to get the signer. And then I'm using it to get the account and then sign transactions. So that's why I'm not connecting because automatically I have an account here. But normally, if you are deployed on Sepolia, you are supposed to be connected on cartridge controller. The setup is very easy. You just check up the cartridge controller setup, as easy as Starknet JS. But then just know that for this tutorial, everything we are doing is on Katana local environment to help us ship as fast as possible. So the next thing I want to do now is to generate what we call TypeScript bindings. So much of times after we have finished writing all our contracts here, and then the manifest has exposed the ABI, there are certain TypeScript bindings that are going to convert all the necessary types, the models, the events that have been indexed. It's going to convert all these types for us to a TypeScript format that we can be able to read on the front end. So that's what we are trying to generate now. Many a times people forget to do this. That's why you are trying to implement your front end, it doesn't work. So to generate it, you have to be in the same directory as the manifest folder. So this is the manifest, and the manifest exists in contracts. So I just do this, and then I'll go to contracts. So in contracts, I'm going to generate the bindings now. So to generate the bindings, I say sozo build. TypeScript, blah, blah, blah. Yeah, then I'm going to set a location where I want it to get all the output. So after it reads the manifest, it's going to generate the output, which is going to be the new TypeScript types. And then the new TypeScript types, I don't need them in the contract folder. I need them in the client side. So that's why I'm checking out here, and I'm going to client, and then I want to paste it in client/src, which is a source folder / a new folder called Dojo. If it doesn't exist, it's going to create it for me / Dojo config. Oh no. No, just /Dojo. That should be coming, guys. Sozo build. Dojo. Okay, let's just do it in /Dojo. Yeah, that should work. or unexpected arguments. Okay, no, it's not supposed to be in word or attempt. It's supposed to be in client/SRC. What now? Let me just do it this way. Since the type is giving me an issue, the location. So let me just build it without specifying the location, and then I copy and paste it there. So now it generates the bindings. Let's hold. Good. So it generates the binding. If you notice, there should be a new. Is it new? Yes. So you can be able to see a new folder here called bindings. And then we are going to copy it and then move it to the client side. So let me just do that real quick. So this command is going to copy it to a client directory. It said not a directory. Oh, so let me create a new directory in SRC. Sorry, in the client side. So let me create a directory called Dojo. You don't have to do this. You can just click the folder and create it. If you notice in clients now, a new directory should be created in SRC called Dojo. It's empty, but now I'm going to copy all the necessary stuffs there. So I just paste the code to copy it. So you can see all the bindings are generated are currently there. Then lastly, I'm going to copy the manifest.json to my front end too, because I need that when reading stuffs. Nice. So now I have everything all checked in on the front end side. I've generated my bindings, which are TypeScript types. Let's look at them. You can see this is for the contract, the actions, just flipping. So you model the execution for us. You can see how Dojo makes life easy for a developer. Then the manifest that contains the ABIs, the contract name, the rest of them. Then the models. These are the models. This is what the game look like. Before, game ID is U8. But this time around, you see, sorry, game ID was U32, but now in TypeScript, it is type big numberish and the rest of them, so that the front end is going to understand this. Many a times, like in Cairo, we have to do the type conversion ourselves, right? But Dojo automatically, with the bindings, does it for you. So that's why many people try to integrate their front end and it's not possible because they forget to generate the bindings. So we are good to go. We've already done that. So next thing is to create a Dojo configuration file. We have 10 minutes. All right. So we'll try to make this as concise as possible. At least I've already explained the concept. So we'll try to finish up this class real quick and couple everything so you guys can watch in your free time. So I'm going to create a Dojo config file. And then I'm going to do this in the Dojo folder, which is here. So that it contains everything that contains Dojo. I'll just say Dojo config.ts. So in this place, I'm going to write all the necessary configuration I need, like the address, making the call to this account and the rest. But in a traditional sense, this is only for development. You can't do this in a production environment. In production, you have to do the wallet connection with cartridge. So go to the documentation and do that. All you just have to do is to remove where we are making the account call and put this. I will show you where you just make the changes. It won't pass more than 2 code and you are good to go. So we also get the Tori URL. On default, it's showing in localhost 8080, the Katana 5050. Then we have the manifests, which we got from manifest.json that contains the ABI and everything, which is here. If you read it through, you'll know. So that's the Dojo config. The next thing now is I want to create a hook that is gonna handle all the Dojo initialization, the contract, the world setup, the account setup, knowing who the client is, and stuff like that. So that's what I'm gonna be doing. So instead of creating a hook folder, let me just do it here. I'll just call it use Dojo TS. And then this is the code for the setup. You see, we get the word setup, we get it from the bindings, which is automatically generated from contract gen here. We bring the account interface from Starknet. For those of you already integrating, you are familiar with this. Then we set up the Dojo context to know if there's an account connected, if the client is well done, and then if it's loading or there's an error. So lastly, from the Dojo config, we get the Katana URL, who the master caller and his private key, which is definitely supposed to be an account, right? Then here is all the states. Then we have a use effect here that first of all is going to set up the account. So to initialize Dojo with this setup, what we are just doing here, we are trying to initialize a new account. And then if you pass in new accounts, which is gotten from Starknet, you pass in a private key and an address, it's going to give you the account, this thing. It's going to give you like the account interface that you can use to be able to make calls within your Dojo system. Then lastly, we set up the Dojo provider. But in a normal sense, like I told you guys, it's going to be wallet connection. So if we're out of deployment, you have to take this out. Then lastly, we set up the accounts. Then we console.log the stuff and dojo.ts is done. So lastly is to set up the Apollo client. So the Apollo client is what is going to be reading all the necessary GraphQL call, right? Like I showed you guys after we made the Sozo call and we went to the port 8080. Well, I'll still show you. So I call this apollo.ts. And then I copy and paste the code. So what does this look like? This is the setup. You get the Tori URL, which in this case, port 5050 or so. No, 8080/GQL. That's the Tori 8080, then /GQL is going to be the HTTP link. You set it up in the Apollo client, and then you can set up in-memory caching so that it caches your data to read it real fast. Then you can get your data, your query structure with GQL, which you are going to use to query your stuff. For those of you that have been working with the graph, this is what your query is going to look like. So this time around, I'm getting coin flip player models. That is the model of a player. And then the key is the address. I'm saying at the end of the day, give me back the address, the total flip, how many wins, and then the losses. So one sweet thing about GQL, the difference between GQL and fetch that makes it GQL better is that with GQL, you can be able to determine the data that is being returned back to you. But in your REST call, it depends on what the server wants to send back that has been stated in the response that it gives back. But here I can select what I want from the response and what I don't want. So that's what can make things faster. And with this, you don't get to use unnecessary data where you don't want to. So this is what the queries look like. And then we'll get them. Then you guys remember displays, right? So this is exactly what I'm doing. This query that is getting the total flip, the wins to show on the front end. That is where I'm doing the setup. Yep. So we are good. So with this, Apollo client is set up, everything works well. The next thing now is to build the UI of our application, which is the last and important thing. So since we have just 3 minutes, that should work. I'll just copy and paste the code in app.tss. I replace. All right, so this is it. Just your regular setup, the state. It handles the fetching of the player state. And then you see to fetch the player state is super easy to show to us. You just call Apollo client, then the query, you pass in the query, and then the response you will get back. This was all modeled here. But I think player start response. Then we can also fetch latest game, which is same thing. Then finally do the flip. So this is how flipping is being done. So automatically from Dojo, we have already set up the client in the Dojo config, right? I'm sorry, in use Dojo here. We have already set up the world client, which we did from the provider, and then we set up the world from the contract gen, right? So that's the same thing we are doing here. So that client is what we can be able to use to make right calls. So this is the flip function. So first we check if there's a client, that is Dojo World is set up, an account is connected, which in this case can be any of your accounts. In this case, you see I'm using a local account. But normally you can also work with your account that is connected from cartridge. So if you integrate cartridge, this is where you integrate the account and you are going to be good. Then we await the call. So client.actions, then .flip. So to call the flip, we pass in the account, which is what is going to be the account making the call, then the prediction of the person, whether it's 0 or 1. Right? Then we wait for this to resolve, and then we fetch the latest game state, which is what we have written down from the GQL calls. So normally in the Rex system, where bigger stuff use, you can work with entities. So these entities are your players. So if a player make any updates, automatically you subscribe to the entities, and then any update made by the player is going to fetch information and give you on the front end. So if you are interested in that part, I will advise you explore it much better. But for the sake of this class, I can't be able to do that. So that's why I work with this method. All right, so that should be it for the front end. It has a button and then 2 buttons that say heads or tail, then the coin that flips, and then the player starts. So we can be able to run the front end to be sure all is working fine. Though I'm getting an alert here. So I think it should be a compilation issue, because I have latest game, I think I have game start response here. I have all the 2 response. So let's see, supposed to be. Let's see if this will fix it. So let's start the system again by saying PM run dev. It's past our time with 1 minute, but we should be done now. So the front end has started. Now let's click on it and check it out right on this spot. What's happening? So let's check it out from the browser and try to debug. So why can't we get this information? The console should tell us. Just if something went wrong. The requested module, this does not provide an exported name big numbrish. Okay, so this should be a Starknet issue. Starknet does not export big numbrish. So where do we get big numbrish from? Could it be the Starknet version? I suspect that. So let's install the latest. That should be the problem. PM install. Because the latest does it. I just pray it doesn't worsen things. So it's still persisting. All right. Let me reconfirm. So let me just paste this error and try to get it as quick. This is a TypeScript error.
So somebody dropped a message in the chat box.
Okay. What does the message says? But we don't have time. Can you just read that for me while I just fix this?
He fixed it from his end. So import type, you write type before the big numberish.
Oh, okay. Yeah. So, yeah, I just saw it right now. My AI just told me. Cool. So let's see. This should work.
I mean, the type will be inside the curly braces, like inside.
For real?
Can you hear me?
Yeah, I can. Like where here, but it specified it outside there.
Yes, that side.
So I have one more error. Okay, so let me check this one too. So all these are TypeScript issues. I don't know why. Okay. They said it's a TypeScript issue in TS config.
We should be concluding.
Okay. I've seen verbatim and erasability are both in one place. Let's remove one. Okay, fixed. Now what's happening again? Okay, I think it's a ts.config change. Do I need to restart? That doesn't fix it. Okay, so it's not only in, okay, I've seen the issue now. It's also showing the same thing here. Oh, there are a lot of errors. Okay. So since there's no time, let's just get AI to fix this for us. So what's also sweet thing about Dojo is that you could build, you could vibe code with it also. It's fully possible. Mm, should I tell it to study why my is showing white? Type issue. All right, so let's see what it tells. So in the meantime, I'm going to be sending the link to this project so that you guys can be able to clone it and try it out by your own self.
Hello, Manoah.
Yeah.
Yeah, we should be rounding up.
Okay,
I
okay.
don't know how big what you have still is.
No, it's not that much. It's just a simple fix.
All right.
This is doing the right thing.
I don't know how, sorry, sir. I don't know how Starknet front end works, but for
Okay,
normal
let's
React
just try
projects,
it.
hello, can you hear me? I know.
Yeah, I can.
Okay, I don't know how Starknet front end works, but then is there any provider that we need to wrap around our layout? Because I've encountered issues like this before in normal React projects. And maybe if there is a provider that we need to wrap around our layout. And so,
Yeah, so it's the same setup you are doing for if you are integrating cartridge, you see it. So it's super easy. It's the same thing. With cartridge, all you just have to do is it's the same setup with was what they use. Is this Starknet? The normal Starknet provider setup, the connectors and all those things. It's the same thing you are still going to work with. Starknet JS. Then you set up the provider that you are going to wrap around. Then you set your connector as cartridge connector. Then it's going to be able to make the connection for you to allow you to be able to interact. Is that
okay,
clear?
sir, that's what I said. That are we wrapped? Like, is it wrapped already?
No. For this class, like I said, I explained this earlier. This class is we are building on Katana, which is a local development environment. So on Katana, we already have accounts that is already deployed for us. In the last class, I said it's like Anvil. So the account and private keys already set up for us. So we don't need to do all of those stuffs again. Is that clear?
Yes, sir. Yes, sir.
Okay, so let's just use like few minutes to just round this up. Let me do a few stuff real quick to see if it fixes. It should be. Let me switch the TX configs. All right. So this should be like TypeScript related issues because these are already proven to work. So as you can see, this is just the problem. It's a type and must be imported using type only import verbatim. Is that what it means here? Oh, magic. Nice. So this is it. Now we have the front end, heads or tail. I think the styling is not loaded yet. Yes. So let me just load the styles real quick. I'm so sorry, country cousin. We'll be living here now. I just want to leave them with something that they could use to build without even being in class. So let me just replace the app.css. Yeah, and these are game. So you could see all our flips are currently loaded. We have 2 flips. We won one, we lost one. The same thing that says in the GraphQL. And let's try to click now. So we are flipping. It says 3. We try tails. It says this. And we can check our GraphQL to be sure everything works the same. You see the same analysis. 4 flips, 1 win, 3 loss. I can check it in the 4 flips, 1, 3 loss like that. So lastly, cartridge. You could just rush to the cartridge documentation and then go to the controller to start the setup. It's super easy in get started. You do this in less than 1 minute, and then you can use the account to interact with Dojo. Then you get the front end. So thank you very much for your time. And with this, we have come to the end of today's class. Thank you very much, guys.
All right.
Are we still taking questions? No.
Of course, if anybody do have question, you can ask. And
Yeah,
Okay.
you promised to show us how to deploy on testnet with dash dash something. You were talking about it that we should, if you remember, you tell us.
Okay. So deployment to testnet is a little bit like different. So let's just do this real quick. I'll show you guys in the documentation. It's there in the Dojo docs. But if I say I want to deploy now, it's going to take our time. I already passed time for the class, but I'm very much available anytime in my DM. You could check me out. I'm available to answer you. But in the Dojo documentation is somewhere. So you see, here you say Dojo 101. This is where the best place to start up, I told you. Then we have deploy to mainnet. So this shows you where to deploy to mainnet. And then there is a script. So first you have to set up your profile, then you set up your dev on your dojo_sepolia profile, which has all your private key and the rest. But your private key is going to be in an env file. So you create a new env file called .env/. Everything here will show you how to do that. Like with the current thing I have deployed, if you get the code and you clone, if you follow this setup, you can deploy to Sepolia even this night. It will work out. So the most important thing in the deployment is this one, which is the script. So what the script does is that it loads the env file from env.sepolia, gets your private key there so that it's going to be secured. Nobody will see it on GitHub. Then you exclude the file from GitHub. And then after it loads it's going to try to run the necessary stuff to build. So you can see the building now. Instead of it doing sozo build, inside this script to do the building and to do the migration for you. it will do sozo-p sepolia. So it's telling the setup that, hey, I want you to work with sepolia setup. So instead of using dojo dev.toml, it's going to work with dojo sepolia.toml this time around. And then it will run the build, then run the migration for you to sepolia, and then automatically it will get deployed. So the account that you are using on, what's it called? The account you are working with for the deployment, make sure it has about some amount of ETH, about 0.01, or some amount of stack. The documentation says ETH, so I will recommend that. Then finally, when the script run, it's going to give you this. Then make sure you make the script executable. Then it's going to run the same thing, the same deployment it did for us. Then it will give you the word at the end of the day. Then it will show you how to index your smart contracts world on Sepolia directly with Tori and slots. So it's also going to introduce you to one new concept called slots, which is the Tori that exists online that is going to help us get our data in real time. So enough of the talk. This is just it, right? Any more questions? All right, boss. I think we are good.
All right. Thank you everybody for coming around today. And do make sure you practice what we've learned. If you have questions, you can always reach out via the channels provided. I hope you're building something for the hackathon as well. So that's that. Do take care of yourselves and good night.